This lesson is find the basis for the null spaces. This is our original matrix. I'm rewriting this down here. And as you can see, there is no extra column of 0. And the reason is we are not finding the vector that span in the null space. We are looking for the basis for the null space. One more time. Since we are looking for basis for the null space, we don't need that extra 0 column. If we are looking for the vector that span the null space, then we need that extra 0. Since we are looking for the basis for the null space, we don't need that extra column of 0. So be very careful. If we are looking for the vector that span the null space, then we need that extra column of 0. Since we are looking for the basis of the null space, we do not need the extra column of 0. Okay, so now we just do the row reduction operations. Since this is already a 1, we'll leave it alone. This is a 0, we leave it alone. And as you can see, this is also a 1, so we're going to leave that one alone as well too. We need this to be a 0, so the opposite of 3 will be -3. So -3 times row 1 plus row 3. So -3 times 1 is -3. -3 plus 0 plus 3 will give me this 0. -3 times 0 is 0. Plus -2 will be this -2. -3 times -3 will be +9. 9 plus 1 gives me this 10. -3 times 2 will give me -6. -6 plus -2 gives me -8. Okay, next we need this right here to be a 0. So that's what I have here. So opposite of negative will be +2. So 2 times row 2 plus row 3. So 2 times 1 is 2. 2 subtract 2 gives me this 0. 2 times -5 is -10. -10 plus 10 gives me this 0. And then 2 times 4 will give me 8. 8 subtract 8 will give me this 0. Okay, and as you can see, there's nothing here, so we are done. If there is something here, for example, whatever that number is, we need to change this to be a 1. We need to change this to be a 0. We need this to be a 0. Because there's nothing here, we'll leave it alone. And as you can see, we have something here. We have something here. So this spot is called a pivot position. This spot is called a pivot position, and there's nothing here, so there is no pivot position for the x third, okay, or x3. So this is x1, x2. This right here is x3, but there's nothing here, so that will become the free spot. Okay, so now we are done, so we will write that out. X1 minus x third plus 2x fourth. Okay, so one more time. X1 minus 3x3 plus 2x4, and that's what I have here. And then just solve for it. So now I have 3x3 minus 2x4. Bring the -3 over, become positive. Bring the 2 over, become minus. Okay, next we have 1 right here. This is my x2. Okay, so x2 minus 5x3 plus 4x4. That's what I have here. Now solve for the second term, so bring the -5 over, bring the 4 over, so I have negative become +5, +4 becomes -4. Okay, this right here is x3. Because it's a 0, we have free space. This right here is x4. Because it is a 0, we have a free space. Okay, so when there's a 0 in the pivot position, then we will have a free space. Next, we will put all the terms in its x. Okay, so gather all the terms correctly in the term in the x that it belongs to. Okay, so based on what we have, we only have x3 and x4. So gather all the term that belong to x3 and x4. So based on this, we have the first term for x3, which is here. We have a second term for x3, which is this 5. We have third term for x3 because 3 is free, so we'll put a 1. We do not have a term for the fourth term for x3, so we say 0. Next is the same procedure for x4. The first term for x4, which is here, minus 2. The second term for x4, which is here, negative 4. We do not have the third term of x4, so we say 0. Fourth term of x4 is 1 because x4 right here is free. Okay, so these are the two vectors of x that is basis for null A. Okay, so when you finish your row operations, make sure look at your pivot positions, write it out, solve for that particular x, and then if there is no pivot positions, if it says 0 right here, then we say it is free. When it is free, make sure you put a 1 in. So one more time, first term for x3, which is this 3. Second term for x3, which is here. Third term for x3 is 1, and the reason is x3 is free. There is no fourth term for x3, so 0. Negative 2 is the first term for x4, which is here. Second term of x4, which is here, the negative 4. There is no third term for x4, so we say 0. This is the fourth term for x4. Why it is a 1? Because it's free. Okay, so these two vectors of x are basis for null A. Okay, next example, same procedure. So here I have another example where my matrices is. I'm rewriting this down here. Okay, since we are looking for the basis for null A or null of that matrix, we do not need that extra column of 0. One more time, since we are looking for the basis. Okay, so let me scroll up a little bit. We are looking for the basis of null space, we do not need this extra column of zeros. Okay, so now we just do row operations, just like the first example. So since this is negative 2, we want a 0 here, just like what I have over here. So the opposite of negative 2 would be positive 2. So 2 times row 1 plus row 2. So 2 times 1 is 2, subtract 2, 0. 2 times 0 is 0, plus 1, 1. 2 times negative 5 is negative 10, plus 6, negative 4. 2 times 1 is 2, subtract 2, 0. 2 times 4 is 8, 8 subtract 2, 6. Okay, since this is a 0, this is a 0, we move on. And we do have something here, which is a 1, so we don't have to worry about it. So now make this 2 become a 0 here. So Opposite of positive, we will do negative. So negative 2 times row 2 plus row 3. So negative 2 times 1 is negative 2 plus 2 gives me this 0. Negative 2 times negative 4 will gives me positive 8. 8 subtract 8 gives me this 0. Negative 2 times 0 is 0 plus 1 is this 1. Negative 2 times 6 will be negative 12, and negative 12 plus 9 will give me negative 3. Okay. Next, as you can see, this is a 0, so we leave this column alone. Now there's something here. So here we have a pivot position. We have something in this pivot position. So whatever's in this column needs to be a 0. Why didn't we change 5? Negative 5 and negative 4 is 0. Because here there is nothing. So we cannot change negative 4 and negative 5. If I have something in the pivot position, then everything in the column must be 0, except the pivot position. The pivot position cannot be 0, but every other terms in the column or number in that column must be a 0. Again, there is nothing in this pivot position, so negative 4 and negative 5 is leave alone. Here we do have something in the pivot position, so this has to be 0, this has to be 0. However, since this is already a 0, so we leave this alone. We just need to change this 1 to a 0. So we need to do the opposite of positive, so it becomes negative. So negative 1 times row 3 plus row 1. So negative 1 times 1 will give me negative 1. Negative 1 plus 1 will give me this 0 right here. Negative 1 times negative 3 gives me positive 3. Positive 3 plus 4 gives me this 7. Okay, now everything is 0 here, so we are completely done, and we can list out our terms. One more time. Here we have a pivot position, so we good. Here we have a pivot position, so we okay. But here there's nothing here, so we move. Since there's nothing in this pivot position, this entire column right here, negative 5, negative 4, we leave it alone. Here we have a pivot position, so any number in this column has to be a 0. Okay, so now we are done. Now we just list out our terms. So here I have x1 minus 5x cubed plus 7x5. And that's what I have here. x1 minus 5x3 plus 7x5, which is I have here. Now solve for the first term. So I have minus, so that becomes positive. Positive becomes minus. Just bring it to the right side. Next, I have something in this pivot position. So x2 minus 4x3 plus 6x5, which I have right here. So again, x2 minus 4x3 plus 6x5, which is right here. Now solve for the second term, and since it's a minus, bring it over, become positive. Positive becomes minus. Okay, next, if you look right here, this is the third term. This is the x3 right here. Since this is 0, it is free. Okay, since this is 0, then it is free. Okay, so now what I have left is just this one right here, the 1. So we need this right here. So if you look carefully one more time, this right here is x3. So x3, okay, x3 is 0. Since it is 0, we say free. Okay, next we have x4. So x4 is this 1 right here. So x4 minus 3x5. One more time. This right here, this 1 right here is x4 minus 3x5, which I have right here. So solve for the fourth term, then bring the negative over. That will come to be positive 3x5. So in this situations, we still don't have an x5. So x5 is also free as well too. Okay, so this right here is x1, this is x2, this is x3, this is x4, this is x5. However, the reason why there's no x5 is because this -3 is already taken from x4. One more time. This is x5. However, it is already taken from x4. So there is nothing for x5. So that's why x5 is free. One more time. This is x1. This is x2. This 0 right here will be x3. 1 is the x4. This x5 is already taken from x4. So that leaves nothing for x5. And since there's nothing for x5, it is free. Okay? Now we write out our term based on our x. Okay? So all we have left, if you look carefully right here, all we have left is just 3 and 5. See? 3 and 5. And there's another 5 right here. So that will be our only x's. Okay? So x3, first term for x3 will be 5, which is here. Second term for x3, which is here, 4. Third term for x3, which is 1. And the reason why it's 1, because it's free. Fourth term for x3, there is no fourth term for x3, so 0. Fifth term for x3, it's also 0 because there's nothing. Now we move on to the x5. First term of x5, which is here, the -7. Second term of x5, which is here, -6. Third term of x5, there isn't 1, so 0. Fourth term for x5, which is right here, 3. Okay, and finally the last one, fifth term for x5 is 1 because x5 is free. So these are the two vectors that are basis for null A.